Look up at the night sky. Every star you see is inside our galaxy, the Milky Way. And beyond it? Hundreds of billions of other galaxies. And beyond those? Modern cosmology suggests something astonishing. The universe may not simply be large. It may be infinite. This idea gained serious traction after the work of physicist Alan Guth, who proposed the theory of cosmic inflation in 1980. According to inflation theory, a tiny fraction of a second after the Big Bang, space expanded exponentially faster than the speed of light. Not matter moving through space, but space itself stretching. Inflation explains why the universe looks flat, uniform, and smooth on large scales. Observations of the cosmic microwave background radiation strongly support this model. But inflation leads to a deeper implication. If inflation occurred once, it likely occurred many times. In fact, in many models, inflation never completely stops. It continues somewhere, constantly generating new regions of space. This concept is called eternal inflation. And eternal inflation suggests something radical. The universe doesn't end. Not beyond the visible horizon. Not beyond distant galaxies. Not anywhere. Space could extend forever. Now here is where the logic becomes unavoidable. Inside any region of space, matter is arranged in a finite number of ways. Why finite? Because the number of particles in a given volume is finite. And quantum mechanics limits how precisely those particles can be arranged. Even though the number of combinations is unimaginably large, it is still not infinite. Your body, for example, contains roughly 10 superscript 2 atoms. The number of ways those atoms can be arranged is astronomical, but still finite. Now combine two facts. The universe may be infinite. The number of possible particle arrangements in a region is finite. When something finite is distributed across something infinite, repetition becomes mathematically inevitable. In an infinite universe, patterns must eventually repeat. Not similar patterns. Exact patterns. That means somewhere, at an incomprehensible distance, there could be another region of space where every particle is arranged exactly as it is here. An identical Earth. An identical room. An identical you. Not metaphorically identical. Physically identical. Cosmologist Max Tegmark categorized this idea as the Level 1 multiverse. In Level 1, the laws of physics are the same everywhere. The difference is simply location. If space is infinite and uniformly distributed, then duplicates must exist beyond our observable horizon. How far away would your cosmic twin be? Estimates suggest roughly 10 to the power of 10 superscript 2 meters away. That number is so large it cannot be meaningfully visualized. It dwarfs the size of the observable universe. But distance doesn't eliminate possibility. It only hides it. At first, this sounds absurd. But it is not science fiction. It is probability theory applied to cosmology. Imagine shuffling a deck of cards. There are about 10 possible arrangements. If you shuffle enough times, eventually a previous arrangement will reappear. Now replace cards with atoms. Replace shuffles with infinite cosmic volume. Given enough space, even the rarest arrangement will recur. This does not require new physics. It requires only two assumptions. 1. Space is infinite. 2. Matter distribution is statistically uniform on large scales. Both are consistent with current cosmological models. We cannot see beyond the observable universe about 93 billion light-years across. That boundary is not the edge of existence. It is merely the limit of light reaching us since the Big Bang. Beyond it, space may continue endlessly. And if it does, then somewhere out there, another version of you is making the same choices. Another version of you made one different decision. Another version of you never watched this documentary. These are not branching timelines. These are distant regions of the same continuous space. No portals. No science fiction machinery. Just mathematics. This idea doesn't arise from imagination. It emerges from inflation theory, probability, and the geometry of space itself. And it leads to a quiet, unsettling conclusion. If the universe is infinite, you are not unique in existence. You are unique only in location. And somewhere beyond every galaxy we can see, in the silent vastness of endless space, your cosmic copy may already exist. If infinite space can duplicate you across unimaginable distances, quantum mechanics introduces something even stranger. Reality itself may split. At the microscopic level, particles do not behave like solid objects. They behave like probability waves. An electron does not occupy one definite position until it is measured. Before measurement, it exists in a superposition, multiple possible states at once. This is not philosophical speculation. It is the mathematical structure of quantum theory. Yet for decades, physicists struggled with a central question. What causes the wave of possibilities to collapse into one outcome? In 1957, physicist Hugh Everett III proposed a radical answer. Nothing collapses. The wave function never chooses. Instead, the universe splits. Every possible outcome of a quantum event actually occurs, but in separate, non-communicating branches of reality. This framework became known as the many worlds interpretation. Under this view, quantum mechanics does not produce randomness. It produces branching. When a particle could go left or right, the universe divides into two versions. In one branch, it goes left. In another branch, it goes right. Both outcomes are real. Both worlds continue. Now extend that principle upward, from particles to people. Your brain is made of atoms. Atoms obey quantum laws. Therefore, decisions ultimately involve quantum-level processes. When you decide between coffee and tea, countless microscopic events occur in neural pathways. In the many worlds framework, every viable outcome unfolds. One branch, you drink coffee. Another branch, you drink tea. Another branch, you spill the cup. Another branch, you never entered the kitchen. Unlike the level 1 multiverse, where duplicates exist far away in space, many worlds suggests duplicates exist in parallel layers of reality occupying the same cosmic region, but separated by quantum decoherence. They are not elsewhere. They are inaccessible. You cannot travel to them because once branches separate, they no longer interact. The mathematics of quantum decoherence ensures the branches evolve independently. From your perspective, only one outcome is experienced. But according to the equations, the other versions of you are equally real. This interpretation has a powerful advantage: it removes the mysterious collapse postulate from quantum mechanics. The equations remain clean, deterministic, and universal. Physicist Sean Carroll is among the modern proponents who argue that many worlds is simply taking quantum theory seriously without adding extra mechanisms. No hidden variables. No special observers. Just the Schrödinger equation applied to the entire universe. If many worlds is correct, branching is not rare. It happens constantly. Every photon interaction. Every atomic transition. Every microscopic fluctuation. Reality is continuously dividing into an incomprehensible number of parallel histories. This does not mean anything imaginable happens. Only outcomes permitted by quantum probability amplitudes occur. The laws of physics still constrain possibilities. But the number of branches grows explosively. The implication is staggering. There may not just be one cosmic copy of you. There may be trillions upon trillions, each representing a slightly different sequence of quantum outcomes. Some versions of you made better choices. Some made worse ones. Some encountered different opportunities. Some never existed due to subtle variations in history. Yet you experience only one thread, a single continuous narrative. Why? Because consciousness follows one branch. It does not jump between them. From the inside, reality feels singular. But from the outside, from the perspective of the universal wave function, existence resembles an ever-branching tree. This raises a profound distinction. Level 1 multiverse, duplicates caused by infinite space. Many worlds multiverse, duplicates caused by quantum branching. One is about geography. The other is about probability. Both arise not from speculation, but from serious attempts to interpret modern physics. However, there is a crucial difference. Level 1 multiverse depends on cosmic inflation and spatial infinity, ideas supported indirectly by cosmological observation. Many worlds depends purely on how we interpret quantum mathematics. And here, the debate intensifies. Because while the equations work flawlessly, we cannot directly observe other branches. They are permanently separated by decoherence, which leads to the central tension. Is many worlds a literal description of reality? Or a mathematical convenience? Either way, if it is true, then the phrase another you is not metaphorical. It is a physical consequence of quantum law. And somewhere, in a branch forever beyond your awareness, another version of you is living a life that diverged from yours at the smallest possible scale. Not across infinite space, but across infinite possibility. Imagine a duplicate of you created down to the last atom. Same memories, same personality, same childhood experiences, same voice reading these words. From the outside, there is no detectable difference. But from the inside, there is. You experience this stream of consciousness, not theirs. This is where physics collides with philosophy. In both the infinite universe model and the many worlds interpretation, duplicates of you may exist. The equations permit it. Probability even demands it. But identity is not just structure. It is perspective. Philosophers have wrestled with this problem for centuries. One classic thought experiment, known as the ship of Theseus, asks, if every plank of a ship is gradually replaced, is it still the same ship? Now apply that to a human being. Your cells are constantly replaced. Atoms enter and leave your body. Over years, nearly every particle changes. Yet you consider yourself continuous. So what defines you? The atoms? The pattern? The memory? The consciousness? If identity is just information arranged in matter, then a perfect duplicate is functionally indistinguishable from you. But if identity is tied to uninterrupted conscious continuity, then a duplicate is not you, it is someone who only believes they are. That distinction may be impossible to test. Humans instinctively assume individuality equals uniqueness. But physics challenges that assumption. If space is infinite, there may be countless exact copies of Earth. If quantum mechanics branches, there may be countless near versions of you. This creates an existential tension. We tend to anchor meaning in uniqueness. But what if uniqueness is only local? Cosmologist Max Tegmark argues that from a mathematical perspective, copies are not extraordinary, they are statistically inevitable. In a sufficiently large cosmos, even extremely improbable configurations recur. This does not make you less real. It makes reality larger. The unsettling part is psychological. If another version of you exists somewhere making different choices, does that affect your responsibility? If in some branch you succeed beyond imagination, and in another you fail completely, which one defines you? From your perspective, only one path is lived. But the theory suggests that existence is not singular. It is plural. Yet experience remains singular. You do not feel split. You do not sense branching. You wake up each morning as one continuous self. This suggests something profound. Consciousness does not experience statistical ensembles. It experiences one narrative. Even in a multiverse, awareness is local. At the center of this puzzle lies one of science's deepest mysteries. What is consciousness? Physics describes matter, energy, and probability. It describes wave functions and cosmic inflation. It describes how universes expand and branch. But it does not explain why subjective experience exists at all. Why is there something it feels like to be you? Some scientists argue consciousness is simply an emergent property of complex information processing. Others suspect we are missing a fundamental principle. If consciousness is purely physical, then a duplicate brain should produce duplicate awareness, separate but indistinguishable streams. That would mean every cosmic copy feels just as real as you do right now. Not simulations. Not shadows. Fully authentic observers. Each believing they are the original. This leads to a powerful realization. There is no privileged version of you. There is only the version you happen to be. In a multiverse, identity becomes indexical, defined by perspective rather than uniqueness. You are not the only one. You are this one. And that distinction changes how we think about meaning. Because meaning does not arise from being the only version. It arises from being the experiencing version. Even if infinite duplicates exist, each one feels singular from the inside. That is the paradox. Objectively, you may be one of many. Subjectively, you are one of one. The multiverse does not erase individuality. It reframes it. You are not unique in structure. You are unique in viewpoint. And perhaps that is enough. The idea of cosmic copies is powerful. But science is not built on emotional impact. It is built on evidence. So the critical question becomes: can we test the multiverse? The concept of infinite space arises from inflationary cosmology, first proposed by Alan Guth. Inflation explains several observed features of the universe: large-scale uniformity, geometric flatness, tiny fluctuations in the cosmic microwave background. Observations from satellites like Planck and WMAP strongly support inflation. But here is the distinction. Inflation itself is supported. Eternal inflation, the version that produces infinite space, is an extrapolation. We cannot see beyond the observable universe. Light has only had 13.8 billion years to reach us. Anything beyond that cosmic horizon is, by definition, unobservable. If space continues infinitely, we cannot confirm it directly. If it ends just beyond our horizon, we cannot detect that either. The evidence supports inflation. It does not directly confirm infinity. The many worlds interpretation of quantum mechanics faces a similar challenge. Quantum mechanics itself is the most experimentally verified theory in physics. Its predictions are accurate to astonishing precision. But interpretations differ. In 1957, Q-Everett proposed that the wave function never collapses, that reality branches instead. The mathematics works. But here's the problem. All interpretations of quantum mechanics make identical experimental predictions. Whether reality collapses into one outcome or splits into many, the measurable results are the same. There is currently no experiment that distinguishes many worlds from alternative interpretations such as Copenhagen or objective collapse models. This creates a philosophical tension inside physics. Is many worlds a literal description of reality? Or is it a mathematically elegant story layered on top of equations? Physicist Sean Carroll argues that removing collapse simplifies the theory that the Schrödinger equation should apply universally. Others argue that multiplying universes without empirical necessity violates scientific economy. The debate is not about math. It is about ontology, what truly exists. Science traditionally requires falsifiability. A theory must be testable in principle. So where does that leave the multiverse? There are three positions within the scientific community. Position 1, indirect evidence is enough. If inflation is strongly supported, and inflation predicts eternal inflation in many models, then the multiverse is a natural consequence. It may be unobservable directly, but logically implied. Position 2, it's metaphysics, not physics. If something can never be observed or tested, it lies outside empirical science. Position 3, future physics may reveal signatures. Some theorists suggest collisions between bubble universes might leave subtle imprints in the cosmic microwave background, patterns we could one day detect. So far, no confirmed evidence of such collisions exists. The many worlds multiverse is even harder to test. Once quantum branches decohere, they cannot interfere again. By definition, other branches are inaccessible. This is the scientific boundary. Cosmic copies may be mathematically inevitable, but currently beyond observational reach. That does not make them false, but it does place them at the frontier of knowledge. Throughout history, boundaries have shifted. Atoms were once theoretical. Black holes were once mathematical curiosities. Gravitational waves were predicted a century before detection by Albert Einstein. Today, multiverse theories occupy that same uncertain edge, grounded in established equations, yet extending beyond direct confirmation. So we stand in a unique intellectual position. The mathematics suggests duplicates. Probability suggests repetition. Quantum theory suggests branching. But the telescope sees only one sky. And the laboratory sees only one outcome at a time. Which leads us to the final question. If cosmic copies exist but can never be reached, what does that mean for the life you are living now? If the universe is infinite, if quantum events branch endlessly, if duplicates of you exist somewhere beyond reach, then a disturbing question emerges. Does anything you do actually matter? In a level 1 multiverse, another version of you may have made every different choice. In the many worlds framework proposed by Hugh Everett III, every quantum permitted outcome unfolds. Success exists somewhere. Failure exists somewhere. Every regret is avoided in one branch. Every triumph is achieved in another. At first glance, this seems to dilute significance. If all outcomes occur, does effort lose meaning? But this reasoning contains a subtle mistake. Meaning is not defined by exclusivity across the cosmos. It is defined by experience within a branch. You do not live across infinite realities. You live here. Probability may generate countless versions of you, but consciousness selects one path not by choice, but by structure. Awareness follows continuity. Even in a multiverse, your decisions shape the only narrative you will ever experience. That is not diminished by copies. It is intensified by isolation. Human history reveals a pattern. We once believed Earth was the center of the cosmos. Then the Milky Way was revealed to be one galaxy among billions. Then our galaxy became one structure in an expanding cosmic web. Each step reduced our centrality. The multiverse may represent the next step. We are not unique in space. We may not be unique in structure. We may not even be unique in outcome. But uniqueness was never the foundation of value. Consider this. Even if there are infinite stars, the star that warms Earth matters to us. Even if there are infinite planets, this one sustains your life. Even if there are infinite observers, you are the one reading these words. Perspective creates importance. In an infinite cosmos, centrality disappears, but locality remains absolute. Your experiences are not averaged across the multiverse. They are lived in full resolution here. If cosmic copies exist, they are unreachable. You cannot communicate with them. You cannot compare outcomes. You cannot merge timelines. They are theoretical consequences of mathematics and probability. And that distance, whether spatial or quantum, preserves something essential. Responsibility. Because while infinite versions may exist, this version of you does not experience their lives. You experience yours. Physics may suggest repetition, but experience remains singular. There may be another you who made a different choice, but that does not erase the weight of your choice here. In fact, it reframes it. In an infinite reality, meaning is not cosmic. It is local. It does not come from being the only possible version. It comes from being the experiencing version. Perhaps that is the deeper revelation of the multiverse. You are not the center of existence, but you are the center of your experience. And in a universe that may stretch endlessly, that may branch endlessly, that may duplicate endlessly, this single thread of awareness is the only one you will ever know.
Subscribe Info Beyond Borders now for more mind-blowing knowledge.